SwayamPrabha. Digital India. Educated India.
Good morning. In the last two classes, we defined an explosion as being produced when a blast wave is generated, and this blast wave is generated due to impulsive or rapid release of energy. Let us qualify it a little better. Supposing I have a region or a zone or a small volume in which, let us say, some energy gets released, and then what happens is this energy release drives the blast wave which propagates out, and then what is happening is the energy release gets redistributed. This energy release in this small volume gets released or gets redistributed by the lead shock wave, and this energy is at this particular time when the blast wave is here, the energy release gets redistributed here. When the lead shock wave is here, the energy gets redistributed in this zone, and so on. It is essentially the redistribution of energy which is impulsively deposited which leads to an explosion. Now, when we say about this redistribution of energy, it is this potential energy of the explosive or what is being released here which gets converted into kinetic energy and potential energy, but it is all contained within the lead blast wave, as it were. There is something important in this, and we have been telling this repeatedly in the last two classes, namely that the material does not move, it is the energy which gets redistributed. I think this point must be kept in mind as we go along. We also told ourselves, well, there were 2 points we said. If this energy release gets into the thermal energy of the medium, well, it is unavailable energy. This is unavailable for driving the blast wave. Second, we also told, since the energy is redistributed, when the blast wave or when the wave continually decays out and reaches a faraway point, that means we are looking in the far field, well, the energy could get conserved. We will take a look at it in the subsequent classes. Therefore, this is the way we defined an explosion, and we found that anyway the lead shock is something which is continually decaying. In other words, what did we tell ourselves? On a streak diagram in which the y axis is t, the distance is x, or very often we will define it as the radius from here, let us say rs. Well, it decays out. Initially it travels a longer distance for a short time, then it becomes an acoustic wave in the far field. Then what is going to happen? See, it is continually decaying, the energy gets redistributed, it is a terrible transient problem, unsteady, and therefore, to be able to solve it was difficult, and therefore, what did we do? We went through the non-dimensional analysis through which we looked at the parameters, and we got the dependence saying, well, the distance by which the lead shock travels at some time t after the impulsive release of energy can be written as Rs is equal to A t to the power 2 by 5. The second point, we also said the velocity with which the lead shock moves drs by dt, which we said is equal to Rs, can be written as a constant. Here A is a constant, t is the time, can be written as Rs to the power minus 3 by 2. We also found out the rate at which the blast wave decays, and we found, well, denoting it by Rs dot, and we say, well, I am looking at Rs 2 dot, that is d2 Rs by dt square into Rs divided by Rs dot square, we got it equal to minus 3 by 2. In other words, Rs is positive, Rs dot squared is velocity, which is anyway is a positive number, therefore, it continually decays, and this is what we got from dimensionless analysis. You will also recall, we said there are different types of explosions. We said that the explosion could be occur in nature. We said naturally occurring explosions, naturally occurring explosions. We also talked in terms of accidental. We said, well, in the kitchen something leaks, gas leaks, and all of a sudden we have something like accidental explosions. We also talked in terms of intentional explosions. Maybe intentionally, maybe during warfare somebody goes and drops a bomb at some place, or maybe of late we have these antisocial elements like terrorists who go and plant some mines or explode bombs in some crowded localities. We say these are intentionally created explosions, or we say, well, intentional explosions. We also told, well, an explosion could be used for constructive purposes like airbags for surgery, maybe for making canals and all that. Well, these were the different types of explosions we talked of. Now, in today's class, to be able to relate to the theory which we must develop, mind you, see, we just developed some value of the shock based on dimensional analysis without going into the detailed physics of the problem. But we also found, well, when I have this lead shock, across the lead shock there is a jump in pressure, a spontaneous jump in pressure, because the shock wave from the ambient pressure, it jumps to this value. Behind it you have the momentum of gases or the impulse of gases. It's necessary for us to determine these quantities to find out what is the effect of the explosion on the things around it. Therefore, to be able to do that, if we can go through some of these examples of different types of explosions, maybe we will be better equipped to understand the theory. Therefore, in today's class, what I do is, we will take a look at different types of explosions and see how they behave, and based on that we will go back and try to again revisit the blast wave generated from the energy source and find out the parameters of a blast wave which could cause some damage. Having said that, let me come to the first slide which I want to show. I will start with the naturally occurring explosions 1. Let's get started with the slides over here. Maybe the first type of the naturally occurring explosion, which all of us are familiar, is something like a lightning. See, this particular slide shows a lightning here. What happens is, you have the clouds which move, and during the movement at high velocities they pick up a charge, become charged as it were, develop high potential or high voltage, and it earths to the ground, and you have something like an arc discharge. I took this slide from National Geographic, and what you find is something like an arc discharge over here. And what happens? The arc discharge releases rapid energy over here, and therefore what would happen? Let's go back and see what could happen. See, you have something like an arc discharge taking place, something like a line discharge, and therefore I will start creating something like a cylindrical wave which propagates out from here. This is Rs dot, that is the velocity with which it goes. In the near field, what is going to happen? I again plot the t versus the x, or the distance, let us say Rs over here. Initially it starts at high velocity, decays out. In the limit wherein the wave travels to far away, I hear a rumble of thunder. If I am near to this, I hear an extremely loud bang, loud thunder, and far away I just hear the rumble of the thunder. We looked at this. Well, this is the first naturally occurring explosions. Lightnings are frequent. In some places it occurs more often than not. Well, this is the first type of naturally occurring explosions. Let us go to the next type. The next is the volcanic eruptions, and in this picture again from National Geographic, I show a volcano spewing out fire as it were. I have a huge fire, and in this hot gases are generated. The hot gases sometimes are charged, and therefore I could get arc discharge, and something like a lightning I could get a blast wave. But very often what happens is, some of these volcanoes, when they erupt, there is also some seismic activity, like there is some tidal waves, and or else the volcano is in the ocean. And very often during the volcanic eruption, some seawater enters into the volcano. The volcano is spewing out these hot gases, hot lava is what is there, molten lava is there. When water enters, this water sees this huge hot mass of lava and hot gases, it spontaneously flashes into vapor, it becomes superheated, and the type of energy is so high that it creates an explosion, something like a physical thing wherein the phase of the water changes. And we had this very famous explosion at Krakatau. This was something like 40 kilometers west of Java, and this happened on August 26, 1883. Mind you, it is quite old, but this explosion is extremely famous. In fact, what happened in this volcanic eruption is something like over a distance of something like 4,500 kilometers away, the blast could be heard, point 1. Point 2, something like over a distance of something like 500 kilometers, the buildings got shattered. That is the power of this particular explosion. That is, the blast wave generated created real havoc in this naturally occurring volcanic eruption. Such type of eruptions do take place now and then, and of late we have the tsunami, we have water ingressing and all that. Therefore, these are the second type of naturally occurring explosions. We come to the third one, and this is of particular interest because of late we talk in terms of comets. We also talk in terms of asteroids in space. What is the difference between an asteroid and a comet? You know, these are all loosely formed objects in space, and what happens is when these are not planets actually, they do not have a particular type of a trajectory, and the asteroid consists of metal and rocky material, whereas a comet consists of maybe ice, dust and also some rocky material, with the result when the comet approaches the sun or is near to the sun, you know, the ice evaporates and a comet has a long tail as it were, whereas an asteroid having metal is something which is more solid. Sometimes these comets and asteroids enter into the earth, like for instance, I say, well, the earth is here. Above the earth we have atmosphere for something like 15 to 20 kilometers high, and suppose some of the comet or asteroid enters into the atmosphere, it immediately creates the kinetic energy, creates a blast wave, something like a comet is entering, I have a blast wave here to be able to equalize the velocity here and the velocity here. The energy release is so high that it creates a blast wave, and this blast wave can cause damage. And one such comet, one such asteroid, you know, in this slide I show a comet or perhaps an asteroid. It is not very clear whether it is really a comet or an asteroid. It entered the atmosphere at a distance of around 8 to 10 kilometers over a place known as Tunguska in Siberia on July 30, 1908. You know, the blast wave it got generated during this re-entry was so strong that over a distance of something like 150 kilometers, the trees just got felled. Fortunately for us, Siberia being a desert, there were not many buildings around, but buildings got demolished over a distance of something like 5 kilometers, and that is the type of the explosive energy release that takes place during the entry of an asteroid into the atmosphere. It is not that there is just one case of this. You know, you will recall around a few months back on 15th February 2013, over the Russian town of Ekaterinburg, you know, we had a comet entering, and this comet entered the atmosphere at a distance of around 5 to 7 kilometers above the surface of the earth, and the blast wave which it created, the impact was felt at a city known as Chelyabinsk, which is 200 kilometers away from the place where it really entered. In fact, due to this blast wave or the impact, something like 200 to 300 buildings got broken, hospitals got damaged, and in fact, you know, it was a big news in all the newspapers saying meteor rattled Siberian city. Fortunately, nuclear and chemical facilities are safe, they were switched off for some time. And let us go ahead. You know, the big bang from this comet was such that as it streaked over Russia, well, it really caused shock waves, shattered windows, buildings got broken, and it led to something like services like internet, mobiles and all being affected. You know, this is the type of power which is associated with a comet re-entering, and there is a lot of interest in comets and asteroids. And in fact, it was told that it's about the largest size, and now if I look at the size of this particular mean size of this comet, it's around something like 17 meters or so in diameter. It's a very small one compared to what was there over Tunguska. It's something like 30 meters diameter. And mind you, these are all small things which can really cause so much of damage, and therefore there is quite a lot of interest on the blast waves generated when a meteor or a meteor, let us say a comet or an asteroid, enters the atmosphere. And we have this problem like when this asteroid re-entered here, you find this brilliant flash due to energy release over this Russian town, as it were, and the blast wave creating the damage. And since some asteroid is supposed to re-enter the earth, maybe a comet is supposed to an asteroid, I am sorry, is supposed to re-enter the earth around, let us say 2036, maybe there is some interest. I must also point out that one such huge asteroid is said to have re-entered the earth around 6 million years ago, and it is responsible for the extinction of life at that time, including extinction of the dinosaurs. Well, this is the third type of naturally occurring explosions, and the last one, let us see what it is like. We talk in terms of stellar explosions, explosions in the star. Well, you have a star whose life is going to get over, its fuel is consumed, therefore it has just neutrons in it. Because of gravity, the neutrons shrink, it becomes very dense over here, and because of the density it explodes, high density, the neutron explodes, a lot of energy gets released, you have a brilliant flash over here, and I also show something like a supernova, that is a stellar explosion in this. This is again taken from the National Geographic, and what you find in these stellar explosions is, the type of temperature which is reached during the explosion is so very high that the atoms combine to form heavy substances like gold, silver, maybe platinum, and the source of these materials are said to come from on Earth, is supposed to come from the stellar explosions. Well, these are the 4 types of naturally occurring explosions. Having seen these 4 types of explosions, let us quickly summarize over here. The naturally occurring explosions are either, let us say, lightning. Second, we say volcanic eruptions. Volcanic eruptions in which some physical explosion like seawater entering the volcano can release huge amount of energy, like the one at Krakatoa. Maybe we talked in terms of the third type, in which we have asteroids, comets entering the earth. And the last one, we said, well, it could be stellar explosions. The stellar explosions cannot be heard for the simple reason we have vacuum between the star and us, and therefore there is no question of sound reaching us, there is no question of a blast wave reaching us, but we must remember it is the light intensity which is seen, and also we have the electromagnetic waves in form of the cosmic radiation which we perceive from the stellar explosions. Having said that, let us come to the next type of the explosion, namely the accidental explosions. These accidental explosions occur quite frequently. Whatever be the type of precautions we take, somehow or the other an accident occurs. How do we define an accident? Let us first be very clear what an accident means. When we say an accident, it means something like an unplanned event, right? Something which we have not planned, accident. And how do you say, well, anything, when I go across the road, something comes and hits me, say I meet with an accident. Therefore, for unplanned activities, there is always a chance that an accident takes place, and the word chance in Arabic is given by the word azar, something like azar. is an Arabic word, and therefore, whenever we talk in terms of an accident likely, we associate the word hazard. Whenever we move substances which are somewhat likely to cause an accident, we say these are hazardous substances and we must be careful, and most of these substances are hazardous under some condition or the other. Therefore, let us take a look at some of the accidental explosions, and mind you, when we do risk analysis, we will address the hazardous nature of substances and see how to take precautions to avoid accidental explosions. Therefore, I come back to the slide. I talk in terms of accidental explosions. Mind you, in the first talk I said about cooking gas exploding in the kitchen. Maybe there is a stove, maybe a cylinder, the gas leaks, mixes with air, somebody goes and puts on the switch or creates an electrical spark, and bang, the entire building is there. These accidents, even in a metro like Chennai, keeps occurring, and there are something like 3 to 4 such accidents in a year, and you see the building getting demolished, the neighboring building getting demolished. We go to the next one. This also shows the same accident wherein the liquid petroleum gas stored in a cylinder getting exploded over here. Well, it is not only the gas from the cylinder which explodes. In the previous one, well, the gas leaked, it created within the confinement of the kitchen a mixture which could explode. Well, when we transport maybe some substances which are reactive, in this particular case, this happened on something like 24th March 2012, about a year and a half back. What happened is, this was a Korean ship which was carrying an explosive substance or a reactive substance which was toluene, and this toluene is somewhat volatile. It formed a vapor and it exploded, and it resulted in killing of a person. Mind you, at that particular time there were not many people in the ship, but still it caused an explosion, created havoc, and therefore, whenever we say, well, we transport energetic substances, we have to be careful lest an explosion or a blast wave is formed. This is something which has been in the news for quite some time. On July 9, 2013, there was this huge number of oil cars or oil tankers being taken. There were something like 72 wagons being pulled by 9 locomotives in the township near to Quebec in Canada. And what happened was, maybe after parking these wagons safely, the brakes were put on according to the drivers, but somehow the brake got released and the wagons freely rolled. And when the wagons freely rolled, they picked up some velocity and they derailed, one wagon on top of the other, and during this process a leakage of the oil took place. And when leakage of the oil took place, it caught fire, and not only did it catch fire, the heat from the fire increased the evaporation or the pressure in the containment of the wagons, and it led to a huge blast. And in fact, the township near Quebec by name Las Magnetes got totally devastated. Mind you, the death rate was not very high, but even then it was a major explosion. This shows the burning after the explosion, maybe the oil spill getting burned, but mind you, it is a major tragedy. That means the spillage of oil from tankers causing an explosion. I will examine this a little later, but in our own country, we have these on the roadways we move liquid petroleum gas in tankers, and when it hit a particular vehicle in the Kerala state near Quailon, this was on December 31, 2009, the LPG spilled, caught fire, but somehow the fire personnel were able to douse the fire without it really exploding. Mind you, therefore, maybe it points towards some precautions which we must take while handling the spills from tankers, oil tankers. Well, this is what really happens. What happens is, a vapor gets generated, the vapor burns, or rather you have hot vapor which rapidly burns, forms a blast wave, and this is what happens in these oil tanker explosions, namely a vapor cloud gets generated. One of the well documented oil tanker explosions, this happened in the city of Illinois in US. This was in Crescent City, and this was done by Professor Strelov. In fact, the previous picture which I show is also from him. And what was done was, he was the first person who looked at accidental explosions in a major way. And let's take a look at this particular explosion in the Crescent City at Illinois. It was again a number of wagons which derailed. And what happened? Let's take a look at it. This happened on June 2, 1970. In this particular case, you have these wagons carrying, in this case what was being carried was liquid propane, one after the other. There is derailment, one of the wagon jumps against the other, and there is a spill of liquid propane gas. Propane is essentially a liquid, and when it meets when it spills, it evaporates, you form a vapor of propane. And when you have a spill taking place, you have a fire, and this fire, if it heats this particular wagon, the pressure inside it increases. You have hot propane here, and when the pressure increases such that the wagon bursts, you have a huge quantity. Not only does the wagon burst, but have a huge quantity of vapor which gets generated. It leads to a huge ball of fire, and this creates a blast wave. And this is known as a liquid which is getting heated from some other source. You have something like a boiling liquid which expanding, vapor explosion. It is known by the word BLEVE, boiling liquid expanding vapor explosion. This is what causes this explosion. We have such explosions happening in our country at Jaipur, happening in Jaipur, but it is happening in open atmosphere. It is in an unconfined gaseous explosion, and these require some particular attention. We go to the next one. In addition to having something like a wagon exploding, when we have pipelines conveying, let us say, liquid petroleum gas, liquid natural gas, liquid propane and all that, it is quite possible sometimes some leakage occurs in the pipeline. The vapor is released, or the liquid is released, it vaporizes over here, catches fire, and it creates an explosion. There are some typical explosions which I would like to say. One happened at Port Hudson in Missouri. This picture I got from Professor Strelov. You have at Port Hudson in Missouri, wherein a pipeline which was carrying again, I think it was again liquid propane. Let us come back to this example. You have a pipeline. This pipeline was something like 0.2 meter diameter. The pressure was something like 50 bar or so at which it is communicated. There has been some rupture in the pipeline, and the liquid propane is a liquid under atmospheric conditions at temperatures less than around minus 45 degrees centigrade. Therefore, maybe liquid propane escapes. It forms a huge fountain of liquid, and then it evaporates. I get a fog and a smog over here of propane. But this accident, as is seen there, happens in the month of December when it is quite cold, and the surface wind at that condition was not very high. It was around 2.8 meters per second, and therefore the cold propane just collected on the ground, as it were, over the ruptured pipeline, and it gradually moved. There is no ignition source at the point where the accident took place, and therefore it just moves, it keeps mixing with air. And downstream, this was something like a valley was there. There was a building over here, a concrete building, which housed some refrigeration units such that maybe the foodstuff could be kept cool. There was a refrigerator inside, or something to keep the substances cold. And therefore, what happened is the gas, the vapor moves here, it through the crevices in the door and window, it moves in over here, mixes well with air, and since there are some motors in the refrigeration unit, well, it catches fire, develops a blast over here, and there are so many different units here that the flame becomes something like an explosion or a detonation, and you have the blast which takes place, and this blast took place around 13 minutes it took for the mixture to come and form this blast, and once this blast comes, this ignites the whole thing and you had a huge explosion. And this explosion was such that it could be heard something like 50 kilometers downstream, and also it just decimated the place as it were. This is the explosion which is involving liquid propane as it happened at Port Hudson. I come back to the slide again, Port Hudson on December 9, 1970. We have a number of such explosions, and one such explosion is sort of catalogued in literature as being the largest man-made explosion ever. This happened in the Ural Mountains in Siberia, and what was done? You had a pipeline around 0.7 meter diameter. It was conveying natural gas, which is essentially methane, and in this, the pressure, I think it was designed for a pressure of something like 25 bar. It was operated at 12.5 bar, but then over a distance of something like almost like pipeline of something like 1 kilometer, there was this pipeline ruptured, and it was downstream. It was something like 1500 downstream of the supply point of the gas to this pipeline. Nobody really noticed that gas was leaking. Huge quantity of it leaked, and mind you, it was June 14, 1989. The spill accumulated on the ground, does not mix well with air, and at that point what happened is, as fate would have it, let's go back and take a look at this particular accident and how it took place. What happened is, we told ourselves, well, you have the pipeline conveying LNG, therefore over the ground you have methane, low temperature methane accumulating. It does not really mix so well with air. There is no accidental source. After all, it is a Siberian plain, not very well populated, and there are no houses or anything which can lead to ignition sources like spark over here. But you will also remember that if you look at the geographical part, maybe on the east you have Vladivostok, and there is a train which runs from Vladivostok to Moscow. This is the Trans-Siberian Railway, and this is a double railway line, and as fate would have it, this sort of spill took place over a long distance, and there were these two tracks which was there, and along both the tracks, in one the forward train is going from Vladivostok to Moscow, in the other the train going from Vladivostok to Moscow in one train is going, the other one along the other track you have the train going from Moscow to Vladivostok, and both are adjacent to each other, and because of this turbulence which is developed when two trains pass each other, and it has its ability to mix the gases, a good mixture got generated over here, and these being electrical trains, overhead you have the electrical spark which ignites it, and a huge bang took place, and this is the largest man-made explosion ever. It killed all the inhabitants of both the trains, and something like let's get back to the slide, something like 600 people got killed, trees were decimated over a distance of 4 kilometers. And it is not only this pipeline, in many chemical industries you have pipelines conveying explosive substances from one container to the other. Many such incidents do occur in chemical plants. One typical example which is often quoted in literature is the accident at Flixborough in England on June 1, 1974, wherein it just created a ghost town in England, and that town still continues to be a ghost town because of the damage it caused there. Let us go to the next example. Well, so far what does it have done? I have looked at maybe the explosions, accidental, occurring from gas in a confinement, occurring from maybe a vapor in unconfined geometry. We looked at pipelines, we looked at wagon derailment, and now we come to something like solid substances. Like in this particular case, this accident took place on something like April 18th this year, something like 5 months back. And what really happened? This was a factory in the town of West in Texas in US, and they were storing ammonium perchlorate. It is not very clear, the thing is still under investigation, but apparently the ammonium perchlorate, which let us say ammonium perchlorate is a condensed phase substance. Let us take a look at it. We will be looking at some of the explosions involving such substances. Sorry, it is not ammonium perchlorate, it is ammonium nitrate, which is used as a fertilizer. You know, this substance has both fuel and oxygen in it, and if it begins to catch fire, maybe it gets heated and the rate of release is high, and when a particular large quantity of ammonium perchlorate is involved, it goes into this chemical reaction which keeps on feeding back heat to it, and you have such a powerful rate of energy release that a blast gets generated. This is what happened in this particular case at the Texas factory in the town of West, and the entire town of West got decimated. Well, it is a case of a solid substance like ammonium perchlorate, we say it is a condensed phase explosion. We take one or two more examples of this. Let us say, in our own country at Shivakashi in Tamil Nadu, where we make this cracker industry. The cracker industry involves some substances like carbon, sulfur and ammonium nitrate mixed together, which are used in making crackers or making fireworks. And to handle them, even though they handle small quantities, very often we find that not handling them properly leads to the accidental explosion, wherein people die. Every time we hear 3 people dead, 10 people dead, the entire building gets decimated like what is shown over here. Due to a small amount of this composition accidentally igniting, a blast is created, the entire building gets decimated, people die. And one such case which is very well catalogued in literature involving ammonium nitrate is something which I will spend some time on. This accident was in the Texas city in US. This is the southern, it is a port city in southern US. This happened in 1947. What is the thing what we are talking? Again, this involved ammonium nitrate. See, ammonium nitrate, if you see, we said it is NH4NO3, it contains a lot of nitrogen. It is used as a fertilizer, and there is a lot of demand for fertilizer because you would like to fix nitrogen in the soil. Now, in this particular case, we do not want to use the real ammonium nitrate, but we would like to make it a little more resistance to explosion, and therefore, you have wax being coated on the ammonium nitrate crystals such that its intensity of explosion or its susceptibility to burning and explosion is reduced. Therefore, you have instead of AN ammonium nitrate, you have what is called as fertilizer grade ammonium nitrate, which is essentially coated ammonium nitrate, and normally it is coated with wax. In this particular case, you have something like 7,700 tons of ammonium nitrate, all in cartons or bags stored in the hull of the ship. You have all these cartons of ammonium nitrate being stored in the hull of the ship. Now, the hull of the ship is somewhat insulated, heat cannot really go from inside to outside or outside to inside, and if some temperature increases over here, it keeps heating it up, and therefore, what was observed was maybe in that particular accident some temperature increased due to some chemical reactions taking place inside. Always there is some element of reaction taking place, and when they found some smoke in the ship, you have steam which is available, people sprayed water and steam onto the smoke which was being created. Now, the temperature is going up, the steam further contributed to the reaction, and therefore, you have something like a chemical reaction gets terribly increased because of this. There is a spiraling of the chemical reaction, rate of chemical reaction if I say as time progresses builds up, and the rate of chemical reaction becomes so much that high intensity energy is getting released spontaneously, and you have a huge blast wave which gets generated. The blast wave in this case was so strong that the entire hull of the ship got blown off, and it carried over a distance of a few kilometers. Why? Something like almost 600 people died. Over a distance of 16 kilometers from the site of the explosion, well, nothing remained. People got knocked down, buildings got destroyed. Over a distance of 60 kilometers, trees were uprooted, and this explosion from Texas City could be heard at a town 400 kilometers away, and that is the intensity of this explosion. Well, picture shows the damaged cars, maybe the hull of the ship and the buildings being damaged, which I again show in the next slide, wherein after the aftermath of this Texas City disaster, well, nothing really remains. Therefore, this is the type of explosions which keep taking place. And what is it we have considered so far? Let's quickly review ourselves such that we can look at some other explosions and draw some examples. We tell ourselves, well, the accidental explosions, maybe we say yes, an accident is an unplanned event, could be something like a confined one using gases, it could be unconfined, it could be something like wagons derailing and have something like believe boiling liquid expanding vapor explosions, believe. We could also have, we said, solid substances like condensed explosions, in which maybe some chemical reactions occur, like in Texas, maybe at Shivakashi, we have all these condensed explosions. We could also have the confined gaseous explosions in a slightly different context, and I very deliberately brought this point out in the next slide, wherein I show the example of the explosion of a fuel tank. There was this particular aircraft which took off from New York on July 17, 1996. It was the TWA 800 flight, and since it was supposed to go over a short distance, not all the fuel tanks in the aircraft were fully filled with kerosene, or what we call as a jet fuel in New York. It was the summer month, mind you, it happened on July 17th, and therefore, what was done was one central fuel tank was near empty, because that much of fuel was not required for the flight from New York. I think it was going to Europe, and therefore, the quantity of fuel which was loaded was not in all the tanks. 11 minutes after takeoff, the aircraft just exploded, and it was a huge fireball, and an analysis showed that since the central fuel tank was near empty, there was small amount of kerosene in it, aviation kerosene, and on the ground, wherein you have lot of air available, an explosive mixture could not be generated, but the moment it goes to higher altitude, wherein the air is small, a combustible mixture with air got generated, and therefore, at that point some electrostatic spark could have resulted in this particular explosion. It is again a confined fuel air explosion, in which you had a huge fireball, all the passengers and crew of this flight were killed in this particular explosion. This is something which we will deal with in some detail. We will look at limits of flammability of substances, under what conditions you could have an explosion, and we have to address some of these points, including the flash fire point of the volatile liquid fuels. It is not only the gas, the liquid and the solids, energetic solids, but dust can explode. I would like to qualify it further. That is, what did we tell now? Well, I could have confined explosions because of maybe some tankage, maybe you have gas which is a mixture which is formed, which is initially not flammable or initially not explosive, but which becomes explosive under certain conditions. We tell ourselves not only solids and liquids and say gases are explosive, the dust, like for instance we consume wheat flour, we make bread out of wheat flour, maybe we use sugar, maybe we use for icing fine powdered sugar. all these are explosive substances. If it is mixed with air in sufficient quantities, it could explode, and one such thing which is the first recorded explosion was in Turin in Italy. This was on December 14, 1785, wherein you had this particular baker who sends a boy to the godown to collect some flour. I think it was wheat flour or maize flour, I am not very sure about it. And this particular boy, this was December month, it is an evening, quite dark. Therefore, this boy takes a candle in his hand, and in the other hand he picks up the flour, as it were. Being a boy, he is playful, he tosses the flour, and this flour, when it mixed with air, exploded, and this was the first recorded dust explosion. We have such explosion involving dust in large number in US, wherein they handle the food crops in confinement. We had this in Wichita in US, wherein you have 7 people being killed in a dust explosion involving, I think it was a wheat dust. You also have an entire port terminal being destroyed in Brazil in November 2001, which was conveying the grain was being unloaded in the particular port. Therefore, dust explosion is also a type of explosion which could occur. Having said that, we spent a minute or two on the last type of explosions, which we said, well, it could be accidental. We can also talk in terms of physical explosion. We already talked in terms of physical explosions when we talked in terms of the volcano, in which the water got into the volcano, got terribly heated up, superheated vapor formed as an explosion. And in physical explosions, it is essentially a substance which is not a combustible or a high energy substance like water, which can create an explosion. Let us take an example. In a particular place in Canada near Ottawa, at a place known as Flin Flon, you had this copper smelter, and towards the evening, on a weekend day, people want to go home early. You had this smelter, you have a reverberatory furnace or a furnace, crucible furnace, and the furnace is hot, people want to leave early, but they have to cool down the furnace before they leave, the work is over. Therefore, to cool it further, maybe the operator, he takes water in a pail and pushes it into the furnace, which is quite hot at that point in time, and all of a sudden, because of the thermal inertia of the furnace, the water just flashes into vapor and creates a blast wave and injures people. This is the type of explosion which I said happened on, I come back to the slide, on August 8, 2000 at Flin Flon, a town near Ottawa in Canada, wherein in a copper smelter we had flash vaporization driving blast waves and an explosion. Such type of explosion was also, we must remember, in the case of natural explosion at Krakatoa, wherein you had the huge explosion, and this is the type of examples which I collected under accidental explosion. Now, I just spent a minute or two on intentional explosions. Let us come back to this. Unfortunately, the of late we find these terrorists and the anti-social elements engaging in this type of affair, and one such example which I show here is happened at Oklahoma City on April 15, 1995, wherein a nice posh building which housed maybe children, a nursery, was brutally damaged by a blast, in which case a truck carrying solid explosives was parked nearby. Well, it was ammonium nitrate, it was little bit more energetic. We will get back into the details when we study the condensed phase explosion, and the blast wave just ripped off this building. It is not only this type, it keeps happening all over the world of late, in Afghanistan, in Iraq, maybe while in India we have these improvised explosive devices, we have mines being planted, and nowadays we talk in terms of these explosions as low intensity conflicts, and we have to design the system such that maybe the buildings or the or the type of the blast wave could be controlled, or maybe the structure should be so strong so that it does not really get affected by this. Well, these are the intentional explosions, and you will also remember at the Boston Marathon a few months back, we had the terrorists putting the explosive or energetic substance in a pressure cooker and killing people. Well, these are the type of intentional explosions, and before we complete this, I deliberately brought this point of atmospheric dispersion. Why is it atmospheric dispersion? You know, in the example of the Hudson explosion, wherein liquid propane went into the building, it is by atmosphere that it is going, and in fact, you know, we have some cases of atmospheric dispersion causing disaster. One is in our own country, we had the Bhopal gas tragedy, which is stated to be the world's worst industrial disaster. This happened on a cold day, December 2 to 3, 1984. And what really happened? Let us take a look at it, because it gives some room for thinking. In this particular plant, which was a carbide plant, you know, you stored methyl isocyanide in tankages, and you know, you have the valves of this. Somehow, you know, the somewhat like a hood which will prevent water ingressing into this was missing. When it was being cleaned, some water got into the tank, and also the tank was a little dirty. You had something like chloroform, you had some iron inside the tank, and when water comes in contact with methyl isocyanide, it begins to react, carbon dioxide gets generated, and these impurities further led to the reaction. With the result, pressure in the tank got increased. And normally, you know, in the plants you have something like refrigeration coils which will control the temperature of the system. It was December, it was cold, these were not operational at that point in time. Gas got generated, the pressure went up through the vent valve, a mixture of MIC and MIC gas got released. The scrubber was unable to control the mass flow rate of it. The wind velocity was low at around 2.5 meters per second, and being winter time, the temperature on the ground was lower than above. With the result, we say atmospheric inversion. The gas was not able to diffuse out into vertically and prevent the methyl isocyanide affecting the people downstream. With the result, it drifted, and whenever it came in contact with people, either they got blinded or when the dosage went up, they just died over here. That means we are talking of the atmospheric effects. You know, even when we talk in terms of some gas from a pipeline, gas is coming out, you know, the ability for the gas to go out into the atmosphere, we say an unstable atmosphere will allow the gas to get lost, does not happen under certain conditions, and therefore atmospheric dispersion is an integral and an important part of the explosion physics, and therefore we say, well, we could have accidents due to atmospheric dispersion, and the world's worst case was in the case of the Bhopal gas tragedy, in which some 20,000 people were killed. Why? We had also the great smog of London. This happened on December 5, 1952, again in the winter time. During winter time, people burnt more fuel to stay warm, and in those days maybe the type of coal was also not of that good quality. It created sulfur fumes, and it got trapped on over the surface of the earth. This permeated into buildings, and something like 12,000 people got killed. You know, in addition to maybe pollutants and dispersion, we recognize that the combustible gases could also move, mix with air, and therefore atmospheric dispersion becomes important. The last one is maybe in nuclear power plants. You have loss of coolant type of accidents, in which you have hot metal coming in contact with water, generating hydrogen, and this hydrogen exploding. We had this in Fukushima in December 2011, around 2 years back. We had this almost imminent, but it did not explode. This was in 3 Mile Island on March 29, 1979. We had this happening in Chernobyl, and the only thing which was done was the whole thing was encased with concrete and steel, and maybe it was nothing more was allowed to happen. This is the last slide which I show. This is taken from Professor Dewey's work, and what is seen here is, an explosion taking place, you see the blast wave from the explosion preceding the matter from the explosion. This is the blast wave which causes the damage. To sum up then, we talked in terms of different types of explosion, we talked in terms of the largest man-made explosion, we talked of nuclear explosions. Well, we did not get into Hiroshima and Nagasaki, which I talked of yesterday. Well, you could also have fission and fusion, and these again generate. We will not deal with fission fusion, but we will look at loss of coolant type of accidents. We talked of explosion in a fuel tank in the TWA 800. We talked of dust being explosive, maybe the eatable things which in fine powder becomes explosive. In our own country, we have the propellants exploding in one of the assembly points in the Indian space program. We also have the believed type of explosion at Jaipur in an oil refinery on 29 October 2009. We had several such believed explosions at Visakhapatnam. We also talked in terms of the believed explosion at Crescent City in Illinois. Well, these are the different types of explosions, and to just sum up the different categories of explosion, I will just put it in a slightly different form. We tell ourselves, well, we looked at different types of explosions, we find, well, they cause a lot of damage to life and property, and I can tell myself, well, the first type of explosion which I can talk is maybe a condensed phase explosion in which solid substances are associated. It creates more and more heat, it is something like a feedback, and the rate of reaction goes up. Well, it is a thermal type of explosion. We talked in terms of confined gas explosion in a room, in a confinement. We talked in terms of the unconfined, believed type of explosion, unconfined explosions. The fourth one, we said, well, why all this? Even a dust could explode, dust explosions. We talked in terms of the physical explosions. That means some vaporization of the substances taking place. We talked in terms of, maybe we have finished confined, unconfined, solid substances. We talked in terms of atmospheric dispersion. We talked in terms of loss of coolant analysis, maybe the nuclear explosions. Well, these are the different categories of explosion, and having understood these explosions, our next step would be to go back, look at how release of energy from this explosion drives a blast wave. We will try to model the blast wave and try to find out how